Welcome to Study Loop.
We have been given a prism with an apex angle of 60 degrees and a refractive index of n2, which is equal to 1.5. Now we have an angle of entry of a ray into this prism at 48.6 degrees, and we're being asked to prove that the ray is symmetrical as shown in the image that they have provided for us. So this is a 60-degree angle. This is our ray. And of course, this is going to be symmetric and normal to the bottom. So we have an angle entering at 48.6 degrees. So this is theta 1. And this is the normal. No, sorry. This is the normal to the surface. And this will be exiting at the exact same angle. So we want to prove that this angle right here, we want to prove that this angle is the same as this one. So to do that, we're going to have to do some magic. So we are going to say that n1 sine theta 1 is equal to n2 sine theta 2. And since we know that the outside medium is air, we know that's 1. So we're going to want to find angle 2, which is located right. So our theta 2 is located right here. So we want to determine what that is. So to do that, we're going to take sine of theta 1 divided by n2, and then find the inverse sine of that whole situation, which will give us theta 2. Now that will give us sine of 48.6 over 1.5 equal to theta 2. Theta 2 will then be equal to 30 degrees. So we have now determined that theta 2 is 30 degrees. We know that this is 60 degrees. So if this guy is 30 degrees and this is a normal, that means that this angle, which we're going to call alpha, right? Alpha plus theta 2 is going to have to equal 90 degrees, which means that this angle right here, alpha, since this is 30 degrees, alpha is going to be 60 degrees. So that means if we have two 60-degree angles, this one also has to be 60 degrees. That's just basic geometry. All the angles have to add up to 180 degrees. So now we determine that this angle is also 60 degrees. So I'm going to make this a little more clear. Since we know that this angle is 60 degrees, that means that this angle and this angle, which we're going to call theta 3, have to equal, you guessed it, they have to equal 90 degrees because this is a normal, right? This is normal to the surface. So they have to equal 90, which means that theta 3 is equal to 30 degrees. So if theta 3 is equal to 30 degrees, we'll call this, instead of calling this theta 1, we'll call it theta 4. We can say that n3 of, okay, I'm going to have to move this over a little, but the n3 times sine of theta 3 is equal to n4 sine theta of 4. And we know that this is equal to 1 because the outside medium is air. N3 is 1.5. So to find the sine of, to find theta 4, we're going to have to find the inverse sine of 1.5 times sine of 30 equal theta 4. And that, of course, will give us 48.6 degrees, which is equal to theta 1. So that means that theta 4 is equal to theta 1. So that's it. We have successfully proved that the ray is symmetrical on both the entry and exit. So next thing we want to do is part B, in which we have to find what is known as the angle of deviation. So to find the angle of deviation, we need to use a special equation. And that equation is given to you in your textbook. So I'm going to write that out for you. It's n equals sine of the apex angle plus the angle of deviation all over 2. And that is over sine of the angle of deviation divided by 2. Excuse my handwriting there. So we'll multiply sine of the angle of deviation over 2 by n, find the inverse sine of that, and then we're going to subtract the apex angle, and that will give us our angle of deviation. So in this case, for B, right, for B, we're going to have sine -1 of sine of 60 divided by 2 times 1.5 minus 60. And that is going to give us an answer of 37.2 degrees. So for C, we're going to do the same thing. We're going to use the same equation, but this time we're plugging in a theta value hold up. So what you'll notice is that in no part of this equation does the angle of incidence play a factor. So for B, C, and D, the answer is going to be 37.2 degrees because the angle of incidence does not play a role in the angle of deviation. All that matters is the apex angle, the apex angle, the n value of the prism, and that's it. So this is your answer. We have successfully proved the symmetry of the prism at that angle, and we have determined that these three are the angles of deviation for this prism.